I think we can continue. Huh. Okay, so we were here. So I'll quickly explain what serializable and serialization. So in Java, we sometimes need to convert objects to serializable object or and serialized object back to the actual object. We have to do that in order to sometimes send object over network, because sending it in a serialized, we can send it in a serialized way and not in a normal. Serialization is basically converting it to byte code, and we can send it, and then wherever it's received we can create object of that state again, but it won't be the same object. It will have a new instance in the memory, and for that we have to use an interface called implement serializable, which is a marker interface. It just tells the JVM that this class needs is a serializable class. And also we need to, it's a good habit to provide this serial version UID by ourselves, which is a long, so that the JVM knows how to identify each class and serializes it based on the serial version UID. So we till now we have seen how to serialize object and put it in some file, and then read that file again and deserialize the object. Till now we did that, and we were doing that using something called there were two inbuilt classes. There was output object input stream, which helps us to convert deserialized object to serialized object, and there was something like object output stream, which converts objects to serialized objects. So there were two things. Okay, and then we'll try to memorize all this later. First, let's go over all of this. When serializing object, we often need to handle static class field or exclude non-static fields in the serialization. Recall the JVM defines a default way of serializing object. This default includes ignoring static class fields. Okay, so the default way of serializing is done by the JVM, and this default includes ignoring static class field. So it ignores the static class field and it does the serialization. Okay, which belongs to a class and not an object. The JVM also serializes all fields in an object, even those marked private and final. Wait a second, I'll also invite one of my friends. I am revising Java basics. You can join anytime. Please give me a call. Okay. So, recall that the JVM defines a default way of serializing objects, and okay, that default way contains ignoring the static fields, right? Excluding the static fields. Where was that? Default includes static class fields. Okay, which belongs to a class and not object. Okay, we already know about static. The JVM also serializes all fields in an object, even those marked private and final. So, okay, so it serializes all the fields, even those marked as private final. Okay, that's fine. Although the JVM implicitly serializes non-static fields, we can instruct the JVM to ignore them using the transient keyword. Okay, so implicitly it serializes non-static field. We can instruct JVM to ignore them. The field marked as transient will have its value ignored during serialization. Instead, receive the default value for that type of field. Okay, so its value will be ignored during serialization and instead receive a default value. Okay, so let's see how they use it. Private static int, okay, private transient. So they put a transient over here in here, but now if when this is serialized, some default value will be given to yearborn, this variable. In an example above, we define a static field called number of people with a value of 10, and since it belongs to the class, it will, okay, this is static, it will not be included in serialization. We also defined a transient field called yearborn of type int. The JVM will ignore the initialized value of this field and instead serialize the field with default value of its type 0 in this case. Okay, so the default value of this type int type is 0. That's what they're saying. Let's discuss some interesting aspect of deserializing. Deserializing object with transient and static fields. Okay, the deserialized copy object will not get the default value for a static field. In our example, the value is 0. Okay, so the deserialized object will not get the default value for a static field. Okay, in our example, the value is 0. Since a static field belongs to a class and not object, a deserialized static field will receive the value it corresponds in the current class. Okay, so static field is also serialized, but initially it said that it won't be, right? The default includes ignoring static class to class and not an object. Implement JVM to ignore them using the transient keyword. Okay, did not actually make that sense. Okay, so the deserialized object will not get default value for static field. Since static field belongs to class and not the object, a deserialized static field will receive the value it corresponds to in the current class. Okay, so static field will get the current value only. Why does it make it confusing? I don't understand. A constructor is also called during deserialization for a deserialized type object. Object fields are set using reflection. Okay, a constructor is only called for the first non-serializable class in the parent hierarchy of the deserialized object. Okay, a constructor is only called for the first non-serializable class. Constructor is only called for the first non-serializable class. Okay, in the parent hierarchy of the deserialized object. Non-serializable class, first non-serializable class, okay, in the parent hierarchy of the okay, I think we should see an example for this. We often want to serialize all non-static fields in an object. Okay, however, sometimes we may need to serialize transient field if a field's value is dependent on other fields, or more importantly, if we have a reference field that is not serializable. We'll talk about this later. Okay, let's practice using different type of serializable, non-serializable field. Okay, first thing, let's practice the serialization process with static and transient field. We've included a new string a field named model in the car class and modified constructor and main function to incorporate it. Run the program to observe what gets printed when deserializing an object with non-transient and static field. Okay, that's interesting. So they've added this model, private string model. Okay, and that's it. And they made a object here where, okay, they made an object, given it Corolla. Honda Civic is the model. Okay, they've created objects. Then they use they use object output stream to serialize the Toyota object, and they'll put it in which files? They'll put it in cars.txt. So for that we have to put file output stream, which we have created here. And similarly, to deserialize, we have to do object input stream, object input stream, object input, where is it? Yeah, object input stream dot read object, and then it is deserialized. And so object input stream, we have to give the file input stream which has the file where to read from. Okay, so let's see the output, what the output is. So basically what they did, created two objects, serialized it and put it in a file name cars.txt, and then deserialized it, read it from cars.txt, and then they also deserialize and keep the objects, and then they print the objects. Okay, okay, let's run this. Toyota, car make is Toyota, car year is this Corolla, and this car make is the false. Okay, is same object false. Okay, so this was the thing we printed over here. Right, okay, we made a is same object variable and compared this to class. Okay, let's see what it printed. I don't want this. Okay, the car initially, we printed the, did we print? Okay, we did not print this. We directly deserialized it and printed it. So Toyota, car year is 2021, that is fine. Car model is Corolla, that is also fine. Serial version UID we gave it as 1. And then Toyota original was car make is Toyota, car is 2021, and car model is Corolla, and it's exactly the same. Okay, it's exactly the same. Second, let's see what happens when we serialize an object with transient field. Modify model field to and include the transient keyword after private. Okay, so we need to put private and then transient transient string model. Okay, observe the terminal output. Let's see what's the output. So now we see the car model is null. So null is the default value for string type. So that's why they put it as null. Okay, got it. So that's in this article we learned about the transient part. Okay, when we put transient, it is not serialized with the value. It is actually serialized with default value for that type. Serializing associated fields. Okay, so we have been serializing. Where is my friend at? That's the problem. That's the problem. We get distracted. I think We should complete our lecture, then see where is our friend at. Okay. Serializing associated fields. We've been serializing objects. Sorry. Mm-hmm. We've been serializing object. As we've been serializing object, we've not only had primitive type field but also reference types. For example, public class person implements serializable private int private final. Okay, okay. If only. So this is a string name, age and version UID. What is it talking about? In the example, we've defined two primitive types, age and version, and a reference string type name. Okay, so the things which are not primitive are called reference type. For reference type to be serializable, they must also implement the serializable interface. Okay, private string name. For reference type, okay. If the reference type did not implement serializable, then we get not serializable exception thrown. When JVM encounters a reference type, we'll try to serialize the reference type first before trying to serialize the encapsulated object. Okay, I see. Let's look at the class definition and go through the steps. Okay, serializing a person object. So private string, street name, person implements serializable private address. In the example, when serializing a person object, okay. Uh, so if we want to like have a reference type, like address is a reference type, it's not a primitive data type. So whatever is not a primitive data type in Java, that actually stores a reference to the uh, actual variable. So that's called reference type. So address over here is a reference type. So the reference type, mhm, mhm. Okay, so if we want to serialize this, then we should have everything inside it also implement serializable, because the JVM actually serializes this first before serializing the whole object of the person class. So check that the person object is serializable and try to serialize. Okay, yeah. So when serializing a person object, the JVM will check that the person object is serializable and try to serialize the address type. Okay, we'll first try to serialize this. Check that the address variable object is serializable and try to serialize the string type. Okay, then it checks if address is serializable, then it tries to serialize the string type, because that's also a reference type. It's not a primitive data type in Java. Finish serializing the address object after serializing the street name. After it serializes street name, it finishes serializing the address, then finishes serializing the person object. Okay, so that's the hierarchy. Our serializable class will often have a combination of reference and primitive types. but the JVM will perform the same steps as above. If an exception were to be thrown at any point while serializing, it's a reference type. A not serializable exception would be thrown and propagated up. Let's practice serializing object with reference type fields. Okay, let's practice serializing objects with reference type fields. Got it. Let's add a custom reference type field to the class car to see how the serialization process handles it. Okay. We provided a class named engine with the following fields. So public class engine implements serializable private double liters, private int cylinders. Okay, so there's a class and then we have two variables. Add a private engine type field named engine to the class car to fix the errors in the code. Observe the terminal output to see how serialization works with a custom reference type. Okay. Add a private engine type field named engine to the class car to fix the errors in the code. Observe the terminal output to see how serialization works with a custom reference type. Okay, let's do this one first. Okay. Let's add a custom reference type field to the class car to see how the serialization process handles it. Let's add a custom reference type field to the class car to see how the serialization process handles it. Okay, let's add. So let's first make this class public class engine implements serializable private double liters private int cylinders. So we have the serializable class, so we can use this here. So we have engine, and do I have to provide what's the access modifier I have to use? I have private. Okay, so I'll provide private engine. That's it. And then what about this constructor? We can have multiple constructor as well. How many constructor do we want depends. Add a private type. Yeah, we cannot run it at this point, right? Okay, I see. So they have made this, they are assigning this new engine equals to new engine 2.46. They have created in the constructor itself. So what does it say? It says that, okay, I do have to make a constructor, right? So that'll fix that. And then it prints. Okay, so if it prints here, then I also have to give toString method. Public void toString. So toString is a method which gets identified and it gets printed when we use system.out.println. It searches for this toString method. Sorry, public string toString, and then it calls the toString method. So let's return similar format. Okay, string dot format engine make is engine make is percent s. We want percent d for double, and okay, percent d liters, and then percent d cylinders, and then we give here this dot liters, this dot cylinders, and then we can remove all this. Okay, so engine make is this percent d. What's the string formatting we use for double in Java? I forgot. Let's quickly check on Gemini. We use percent d for integer in Java. What do we use for double? Percent f. Okay, percent f. Format. Format specifier. This is a format specifier. I keep forgetting this term. Okay, there's still some error. Class engine is public, should be declared in a file named engine.java. Okay. I think we should also provide a private static final long. But that is not the problem. Private static final long serial version UID equals to 2L, let's say. But this is not the problem currently. I will just remove this. Let's see line number 9. So public class engine, class is public, should be declared in the file name engine dot. Okay, I see. So it's not allowing me to declare it here. So can I make one more file? Okay, yeah, actually I can. I didn't know this. Create a file name should be engine.java, and I can just, sorry, not this one, and I can just use this one. I can use this one. I need to use the headers. What is serializable? So we import the serializable. And what other headers do I need? Do I need something else? I don't think so. Let's run this. But I do need to tell it what that class is because it won't identify the class, right? Okay, it identifies.